Okay, all right. Good evening, everybody. Welcome to the February meeting. We do have, I just want to mention we have the side lights up. There's nothing we can do about it, unfortunately. It's going to be bad for observations, but we just can't get them to budge. So tonight, we have the usual Ottawa skies. We have some astronomy news. We're going to have a presentation from Michael Wolfson about his South African trip. Then we're going to have an update on a talk that we heard a few months ago about the Dominion Observatory. And we're going to end with an extended observation. Our new members already this year, Peter Channon, Louis Cloud, Pierre Fortier, Theresa Fournier, Mike Gignac, and Paul Marshall. Let's give them a warm welcome. And all right, let's jump right into it.
Okay, good evening, folks. So let's take a look at what's happening in the skies for the month of February. Well, there's no full moons this month. That's because we're having 2 full moons in January and 2 full moons in March. Mercury is not visible this month. Venus is visible just after sunset, and Mars is visible in the early morning. Jupiter is visible in the early morning as well. Saturn is visible in the early morning all month. Sorry, my pages are sticking together here. I guess I can look at the screen. Uranus is visible in the early evening all month, and as is Neptune in the first half of the month. International Space Station, the best viewing date. There's many viewing dates, but this is one where it's highest in the sky. It's February the 10th at 6:13 in the evening is where it reaches its peak. This is the path that it takes across the sky. And there's our monthly cartoon. Thank you.
Thank you. And next up is Al Scott.
Good evening, everybody. So this evening I've got a special 20-minute astronomy news. There's no actual particular discovery that I wanted to share with you. For 20 minutes, they just needed me to stretch a little bit, so here I am. It makes it easier. I don't have to decide which news stories to bring to you. So my first one is about galaxy formation and the science of galaxy formation. For a long time, astronomers have wondered about how galaxies formed in the early universe, whether they formed from a top-down process of a gas cloud condensing as one big galaxy, or whether they formed from bottom-up, from several smaller dwarf galaxies or globular clusters accumulating to larger structures over time. So this debate has raged on. The Hubble Deep Field was evidence that pushed astronomers more towards the bottoms-up. If you recall, when they stared at this area of the sky for a long time and eventually found that it was full of tiny little galaxies, and looking at the redshifts in the distance and the sizes and brightnesses, they seem to be smaller on average than galaxies we see in our nearby universe, suggesting that galaxies form somewhat from the bottom up. So according to this theory, the spherical halos in the center of most modern galaxies, spirals and as well as ellipticals, which are all kind of going in all directions, and especially their outer regions, consist mainly of the stellar component of smaller cannibalized galaxies that have angular momentum in different directions from the main flow of, say, the spiral arms. So what I want to show you first is a little animation here. 11 new stellar streams have been discovered, and data from the Dark Energy Survey, currently in progress on the 4-meter Blanco telescope at the Cerro Tololo Inter-American Observatory in Chile. And they provide new evidence for this picture. What we see here is data from the DES survey, including measurements of 400 million stars and galaxies. The survey data extend deep and wide to stars 40 million times fainter than the human eye can see, covering 1/8 of the entire sky. So in this animation, each frame that you're seeing shows stars at increasing distance in the Milky Way from us. You can see the upper left, the little m minus big M is apparent magnitude minus actual magnitude, absolute magnitude of stars. It's a measure of the distance of each set of stars. The stellar streams appear as dark streaks in the top panel and are identified in the lower panel. So you can see what these things are basically thought to be small dwarf galaxies that have been swallowed up and cannibalized by the Milky Way. The DES data have been previously used to discover numerous dwarf galaxy neighbors of the Milky Way. Finding dwarf galaxies is a challenging endeavor. They're faint and rather diffuse. Stellar streams are even more difficult to pick out because their stars are spread out over a much larger area of the sky. You can see the kind of the angular scale of these images. It is 1/8 of the sky. These discoveries are possible because the Dark Energy Survey is the widest, deepest, and best calibrated survey out there. So they do really stand out quite well. You can see that these streaks are here and they're orbiting in different directions in the halo of the galaxy. So this is evidence then, we think, for this bottoms-up view of the galaxy. And astronomers are searching right now in nearby galaxies trying to find these streams, these very dim, faint, broad streams. But they're just kind of below the limit of our current telescopes, and we want to push down just maybe a little bit more to be able to start seeing these streams circling around all of the galaxies. And yet, this isn't the whole picture. There are still questions about how these things form. An international team of astronomers has also determined that Centaurus A, pictured here, a massive elliptical galaxy 13 million light years from Earth, is accompanied by a number of dwarf satellite galaxies which orbit the main body in a narrow disk. The accretion model of galaxy formation suggests that these smaller systems of stars should be more or less randomly scattered around their anchoring galaxies and should move in all directions. Yet Centaurus A is the third documented example behind the Milky Way and Andromeda, basically the only ones we can measure, of a vast polar structure in which the satellite dwarfs seem to co-rotate around the central galactic mass in a preferentially oriented alignment. So we see these little galaxies that are being captured all share angular momentum with the main parent galaxy. So this suggests maybe that they did form from the same cloud with the same sort of angular momentum. So astronomers in these studies have mapped the motion of local dwarf galaxies around the Milky Way and have found that out of the 11 satellite galaxies of the Milky Way, 8 of them are orbiting in a tight disk perpendicular to our galactic plane. Perpendicular to the galactic plane, sorry. There are probably other satellites in the system that can't be seen because they're blocked by the Milky Way's dusty disk. Andromeda presents actually an easier observational target than the Milky Way, and a full distribution of the satellites around Andromeda, there's 27 dwarf galaxies known, and 15 of them are arranged in a narrow plane. And we can measure the red shift and blue shift to see the directions of these galaxies and find that they're in these planes. And so that's really good for Andromeda because it's an edge on it. It gives us very good data on that. Centaurus A is much farther away, and its satellite companions are very faint, making it more difficult to accurately measure the distances and velocities and determine the motion distributions. The researchers in this study were able to find that 14 of the 16 known satellites of Centaurus A follow a common motion pattern and rotate around the plane, along the plane around the main galaxy, which contradicts simulations from random accretion, which suggests only like 0.5% of the galaxy should be in that plane. So the jury is still out. We still don't know exactly why this occurs. This is kind of an interesting thing that's going to go back and help us with the theory of formation to strengthen the theories and find new things that are missing that may explain this. So next news item is a new star cluster, Gaia 1. Gaia 1 is an open cluster which was discovered by ESA's astrometric observatory Gaia last year. The cluster is an open cluster roughly 15,000 light years away, and you can see it just to the left of the black disk here. Unfortunately, it hadn't been discovered previously because it has a chance alignment next to Sirius, the brightest star in the sky, which is blocked out by that black disk. Gaia is a European Space Agency astrometric telescope in space, which has been charting more than 1 billion stars in our Milky Way galaxy. Its next major data release is coming up this April, so stay tuned for some more interesting discoveries. This particular cluster was announced last year, but amateur astronomer Harold Kaiser heard about the discovery of the cluster during a public talk on the Gaia mission and was able to snap this picture on January 10th using his 30-centimeter diameter telescope. He basically blotted out Sirius with a piece of paper on his sensor and was able to snap that picture. So that's a cool challenge for the astronomers. A new open cluster. Next item. For 12 years, a NASA satellite called IMAGE has been lost in space up until very recently. Launched in the year 2000, IMAGE was designed to study the Earth's magnetosphere. After the spacecraft stopped communicating suddenly in 2005, the mission was hailed a success, having helped to map out the Earth's magnetic field in detail and outliving its design life. It had resulted in 37 unique scientific discoveries. NASA listened for it after eclipses in the following 2 years without any luck of the signal didn't reappear. They figured the computer had hung and the batteries didn't discharge enough to reset it. However, earlier this month, a Canadian amateur astronomer happened to be searching for traces of a secret Zuma mission launched by SpaceX, listening in the radio frequencies, when he stumbled upon something entirely different, signals from a satellite that was not accounted for. Scott Tilley was able to use a satellite database to match the signal to the long-lost IMAGE mission, after which he posted it on his blog and contacted the PI, who was somewhat surprised. NASA then set off to investigate it with the Deep Space Network, and sure enough, yes, that's the IMAGE satellite, it's back, and communicating, and sending telemetry. Unfortunately, they had to decode the telemetry by hand because all of the mission control software had been decommissioned and nobody had a Windows 95 computer to reboot the system. So the PI at Berkeley is frantically trying to find a Windows 95 system and regenerate his mission control software so he can see if the scientific instruments may still be working. So interesting, and we're hoping with our fingers crossed that they can make contact and get the scientific instruments up. The satellite actually has another Canadian connection. The far ultraviolet wide field camera optics were built by Cal here in Ottawa as a flight spare to the Freya far ultraviolet camera that flew on a Swedish mission, Freya. So there it is in the bottom left. That's actually a carbon fiber wound tube inverse Cassegrain wide field far ultraviolet telescope. The carbon fiber is wrapped around it in such a way that it's supposed to stay in focus as the temperature changes. Ottawa RASC member Dr. Neil Rowlands actually led the work in refurbishing this and delivering it to NASA. The inverse Cassegrain is an interesting design. It actually has a small primary and a large secondary, so it gives it a very wide field of view, although the focal plane is curved. And this was actually used again on Cal's Caltrack Star Tracker, this design. An interesting story about these optics. I mean, these were sitting on a shelf for years before they were, like the Freya mission was in the early 90s, I believe, and then this one launched in 2000. So this flight spare was basically sitting in storage for some years before it was pulled out. And we tried to find the actual, tests, and it was very hard digging up all the old test data on this thing. We put it together, it was working, we sent it to NASA, and they did thermal cycling on it, and they said, well, did the carbon fiber thing keeping it in focus work? And we said, well, we assume so. It was launched on Freya. It had been tested, and this was before most of us had actually built anything and before our time, so we couldn't actually find any reference to the test data. And it was, I think, University of Calgary had been involved in this way back when it was originally built, and we asked them, and they said, well, no, we skipped that bit because we ran out of money. So it had actually never been tested. And so we asked the Freya team, did you notice anything? And they said, well, we'd always wondered why the stars look like donuts. And it's like, oh, okay. So they actually put heaters on this to keep it at the same temperature so that it would work. But it was a very elegant design. And it worked fine once they got over that bit. And so actually here are a few images from that camera in the 150 nanometer wavelength band of the full auroral oval of Earth. So this is Earth. You can see emission from the sunlit side of the Earth, but you can see the full auroral oval with the wide field camera. And so this was used to track auroral activity. And we're hoping that maybe it's still alive. Looking forward to hearing from the team. So lastly, this is something I've talked to you several times about. An interesting star called Tabby star, or the Where's the Flux star. In 2016, Tabby Boyajian and collaborators, including citizen scientists on the Planet Hunters website, announced the discovery of the most mysterious star in the galaxy. Tabby star exhibited lots of strange photometric behavior. Basically, the brightness was changing in very weird ways, and they weren't periodic. This was discovered in the Kepler data. The Kepler instrument is looking at thousands of stars and trying to see planets occulting the star briefly and dimming the light in a regular pattern over the years. This star had very deep occultations. Up to 22% of the star's light is being occulted over a period of a couple days, and then it would go back, and it wasn't periodic. There were a few weird periods in it, maybe 22 or 44 days, but it wasn't something that repeated continuously. So there was a lot of speculation as to what this was. There was no extra infrared radiation around the star that would indicate it had a heavy dust disk that might be doing this, because dust in a disk around the star would absorb heat from the star and give it off as excess infrared radiation, which would have been detectable. So it was very strange. Maybe people thought a bunch of comets had collided and cold ice was obscuring the star temporarily, but the fact that it kept happening and very deeply and strongly seemed not to be a great explanation. Looking at the spectrum of the star, there weren't any strange spectral features to suggest something strange was happening on the star. Matter was accreting or being expelled. Some folks actually suggested that aliens may have built a megastructure around the star, and that this is what we were seeing dimming the star. And there was a lot of speculation, and a lot of interest was generated, because you actually have to find a better explanation before you can rule that out, and no one could. So Kepler, unfortunately, was unable to continue observing the star after about 2013, so it fell to ground-based observatories to track the photometric accuracy, or the photometric dimmings of the star, and look for the next blips. So in an innovative approach to astronomy funding, Boyajian used a Kickstarter campaign to secure funding for ongoing observations using the Las Cambras Observatory, which is a network of robotic telescopes around the globe. LCO could monitor the star 24/7, providing all the data needed to catch the star's fleeting dips and trigger follow-up observations. So the network began observing the star in March of 2017, and in May of last year, the team caught the first new dips of the campaign, which then triggered a lot of astronomical hardware to go look at the star to see if there was any spectral signature to the dimming, which might indicate that it was a solid structure or not a solid structure. A solid structure, of course, would affect all of the wavelengths in the same way, whereas dust would preferentially absorb different wavelength, and there would be a spectral slope to the dimming. So what they found was that there was a spectral slope. So unfortunately, this is not likely to be a Dyson structure, and the announcement of alien intelligence has to wait a little bit. However, what this means is that based on the slope of the dimming through the spectrum, it indicates that the dust is probably submicron in size, so larger than you might typically expect in interstellar space. So it's probably something in orbit around the star, maybe a result of a collision. And as I said in my last time talking about this, there was an interesting model whereby astronomers were thinking that this could be like a giant ringed planet with huge agglomerations of asteroids in the Trojan points orbiting about it and colliding and creating dust. So this particular observation suggests that it is dust in a rather wide orbit around the star, because it's not warm dust, it's got to be cold dust, or we'd have seen it in infrared. So this most recent paper was put out on the ArcZiv preprint server and should be in astronomy. The paper had over 100 authors, including RASC amateur observer Dave Lane, because various people have been monitoring this from their backyard observatories, looking for the dips and adding data that is being used to track this down. So stay tuned for further information. Based on the model that was presented, the next Trojan set of asteroids should come in the year 2023. So until that time, they're not really sure about what it is, but continuing observations will help us refine the picture and maybe get more ideas of what the dust composes. Maybe there's gas in the dust. Maybe we'll get a better idea of where it's coming from. So a very interesting puzzle, and interesting to see how they worked it out and got the funding to follow up on it. So that's all I have. Thank you.
Okay, so next up, Michael Wilson.
Thank you very much, and pleasure to have a chance to chat with you. We're going to change gears from wonderful stories of discoveries and mysteries of the far outer space to building your own telescope. So I had the opportunity to attend an academic conference in Cape Town last October, and so I emailed, I did a little Google search to see what kind of amateur astronomers I could get a hold of, and it turned out that a week and a half before my conference, the South African Astronomical Society, I forget the name here, there it is, Astronomical Society of South Africa was having their summer star party, wrong time of year for us, but they're in the southern hemisphere, and I was invited not only to go, but to give a talk, and given that I had the chance to present something, I thought, well, I'll bring along a telescope and talk about the telescope, which I did, and so what I'm going to tell you about is the same telescope, which is sitting right here, and during the break or afterwards we can all have a look at it. Where was this place? So here's a map of the southern South Africa, and you see in the lower left Cape Town, and Leeuwenboschfontein is where the star party is. That's about 200 clicks from Cape Town. And I also, if I have a chance at a future meeting, I'll tell you about Sutherland. That's where the South African Large Telescope is, and I took the opportunity while I was down there to visit that and some other nifty astronomical observatories. So as we set out on the road to the star party, there's one of the signs we saw. The place we're going to, let me go back, is in what's called the Little Karoo. The big telescope is in the Big Karoo, and that's basically a really arid, high, cold, dry area. So this is what it was looking like on the road to the Star Party farm. I packed this telescope into a mix of my checked baggage and the mirror itself, and the thing that holds it, called the mirror box, I carried as carry-on luggage. It's a 12.5-inch mirror, and I didn't want to risk putting it in checked baggage. So I put this sign on the outside of my baggage in the vague hope that they wouldn't bother opening it up and messing everything that was so carefully packed. But when I arrived and opened my suitcase, they had clearly opened it up. I guess they thought that on X-ray the stuff inside was rather strange. So this is part of what was inside. So I designed this thing so that a lot of it would fold up and take up very little space, So what you see there is the rocker box and, you know, the main stock. I had to take my hacksaw out, actually radial arm saw, and cut it in half so it would fit in there. Always makes me nervous to do that sort of stuff. And I had a second bag which had a lot of little parts in it. So that's what most of it looked like. And then when I got to the Star Party site, I started unpacking it. So a couple shots of what that looks like. So this is that part before it was assembled. I ended up hinging the side panels that you can see for the rocker box. And that's the carry-on part. Now, that was awaiting me. Now, the thing that I did, which was not a good idea, is I not only carried this mirror box vertically, I also, you know, it wasn't fun carrying it around through several airports, so I also carried it sideways. And inside the mirror box, you can see the mirror. And the mirror wasn't held on by any clips. It was glued to the mirror cell. And so when I went to set it up, the mirror had become detached from the glue. So there was a bit of panic, but the folks there at the Star Party were really nice, and a number of them searched around and they found some silicone glue. So I was able to re-glue the mirror in the morning. And so for the first night of observing, the glue had set enough that I could start putting it all together. So this is what it looked like as I began assembling the telescope. So the mirror box with the black ring is sitting there on the chair on the right, and so on and so forth. You can see it better here. So that's the mirror box, or the rocker box before. I suppose there's a pointer here, but before it was unfolded, and that's it mostly assembled. And here's what the telescope looked like when it was set up for viewing. Even though this was summer in South Africa, or beginning of summer, late spring, it got down to about 0 at midnight, 4 degrees something. So it was pretty chilly. Now, a little bit about the design and the underlying technical ideas in this telescope. My objectives in building this telescope was not photography. You really need a very precise drive. Lots of folks here know that far better than I do. But it was for visual, and it was mainly for looking at faint fuzzies, deep sky things. For things like the moon and planets, a small refractor is fine. And because I live in downtown Ottawa, there's no point building an observatory, too much light pollution. So my philosophy has been to design and build and have telescopes that are easy to carry around both in the car and from whatever dwelling I'm in, whether it's a house or a cottage, from inside to outside, and to set it up quickly. So I need something that's very lightweight and easily assembled and disassembled. So another thing, I don't know how many people have heard the phrase aperture fever. I can't see if you raise your hands anyway. But once you've looked through a telescope that's got a bigger objective or a bigger mirror at the same object, it's pretty hard to go back to a smaller telescope. So I've always wanted to have a telescope with the largest possible diameter aperture. But I also don't like the idea of climbing up on a ladder. I wanted to keep both feet on the ground. So those were the design kind of criteria for the telescopes I've been playing around with. Lightweight, portable, easy to assemble, disassemble, biggest aperture possible, but avoid use of a ladder. So many of you probably know this, but just to quickly review, a refractor is the one with the lens in the front, and they're most expensive. They have very fine images, but they're not practical if you have aperture fever for much more than 6 inches, 150 millimeter diameter. Schmidt cast, not expensive. Larger apertures are reasonable, 10, 12, 14 inches, but they're getting quite heavy. And Newtonians are the least expensive for the diameter, but a 12-inch regular Newtonian telescope can weigh 150 pounds, where an ultralight Newtonian can be, 25 pounds. That's what this thing is. Now, I've used phrases like mirror box and rocker box and things like that. So here's a picture of a conventional Newtonian telescope. I should say that all Dobsonians are Newtonians, but not all Newtonians are Dobsonians. So Newtonian is one that's got a large primary mirror down at the bottom and a secondary mirror at 45 degrees up top. And a Dobsonian is not mounted on an equatorial mount or something else. It's mounted on these things, altitude bearings. So you see the main chunks here, the secondary cage up at the top, which holds the secondary mirror and the eyepiece, mirror box at the bottom, a rocker box, and then in this case there's struts. There's not a solid tube connecting the top and the bottom parts of the telescope. Here's an example of a much lighter weight and larger Dobsonian. And if you look carefully, the struts are actually triangulated beams. So it's lightweight and rigid, but it's still heavy, and this one looks large enough that you'd need a ladder to use it. There's a wonderful book written by Albert High on designing portable Newtonian telescopes, ultralight. So I've read that book cover to cover. He's got some lots of advice and ideas, and including a bunch of engineering things, which I found helpful. One example is, as you'll see, I have just a single strut here, but it's 2 inches in diameter. That's because the stiffness of the strut, and this is something that was clearly documented in the High book, goes up much more rapidly with the diameter. It still can be thin-walled, but you want something stiff so it doesn't flex a lot. There's this really neat light scope that's made out of carbon fiber, designed by a lady in Cambridge, England, actually, and in Germany. During her day job, she builds carbon fiber models of pterodactyls. So she had a lot of experience building ultralight things. So I actually owned one of these for a while. I took it down to Tucson to do some observing, but I found it very difficult to use, nice dark skies there. But because you basically have to be almost lying on the ground. It wasn't at a comfortable height, but it also has some tension, some wires that hold it. So the idea of a tension structure is a nifty one. Anyway, took some inspiration from there. Next bit is there's a lot of discussion in the literature on building your own telescope about, and buying, when you think about buying one, about how you hold the primary mirror. And the idea is, first, is you want a thin mirror from the point of view of rapid cool down. Cool mirror, once it reaches the air temperature, doesn't have as much turbulence around it. And you want to support the mirror so that it doesn't bend. Even though glass looks rigid to the eye without magnification, it does have some flexure. So people have traditionally said, well, for a 12-inch mirror, you need a 9-point mirror cell. And here you see 3 triangles. That's actually what I inherited with the mirror cell in this one. And 3 points on each triangle. And those triangles have lots of degrees of motion, so they can adapt to the bottom of the mirror if it's not perfectly flat. And people get even fancier with larger mirrors. So here's an 18-point mirror cell, 3 triangles on 2 teeter-totters. Well, 3 teeter-totters. Each teeter-totter has 2 triangles, so 18 points. But there's a wonderful piece of freeware software that you can download whenever you want called Plop. And Plop allows you to input into the program a proposed characteristics of a mirror. You tell it what the mirror is made of, plate glass, fiberglass, Zero-Dur. You tell it the diameter, the focal length, and then you say, give me the best support points if I'm only going to have 3, or if I'm only going to have 6, or 9, or 18. And it uses a fancy mathematical technique called finite element analysis. It iterates, and then it comes back with a picture like this, like the 4 pictures I show at the bottom, and says, here's how much deformation you can expect in your mirror when it's looking at the zenith, when it's looking straight up. And the interesting thing, which I certainly verified myself, but I had read first in Albert High's book, was that actually a 9-point mirror is a waste of time. You can do better with a 6-point mirror support. And the little table there says for 3, 6, 9, and 18 points, here's the root mean square, the amount of deformation you can expect in nanometers, the difference between the height at the blue points and the red points in the colored circular diagrams, or the peak to valley difference, and all in nanometers. And you see there's a dramatic improvement going from 3 to 6, but things actually get worse going from 6 to 9, according to the plop calculation. But they do get better going to 18. But it's hugely easier to build a 6-point mirror cell than a 9 or 18 point. And according to the arithmetic, the calculations here, you won't be able to notice the difference between a 6 and an 18-point mirror cell. So the other thing is that most of the time you're not looking at the zenith. You're looking 45 degrees or maybe even close to the horizon. So edge supports also matter. I was lazy, so I thought, well, what the heck, let me just support the mirror on 2 edge supports. That's for a couple of the telescopes. For this one, it's glued to the 9-point cell. But the concern is if you're supporting this round, thin disc on 2 points, about here, as I bang the microphone, maybe the mirror is going to deform in kind of a potato chip shape. And that's bad news, because even if you couldn't see the deformation with your eye, unmagnified, you'd notice it when you tried doing some astronomical observing. So the question is this really a problem? When I look at stars, and there's something called star testing, where you look at defocused stars, if it was doing a potato chip thing, instead of a perfect kind of star test with the concentric circles of diffraction rings inside and outside focus, you'd see things that look more elliptical or even worse, potato chip shaped. This is an easy test to do, and there's lots of books and web pages that explain how to do it. So if you haven't already gotten into it, it's worth checking out in order to get a sense of how good your optics are. My experience was that no potato chip. I could not detect any departure. Maybe my eyesight isn't that good, but as well as I can see stars and galaxies and globulars, I can see the defocused star image, and I didn't see any deformation. So what I want to do now is go through 3 telescopes I've built. I guess I'm a bit obsessive because I get these really nice mirrors on Astromart or cloudy nights or whatever, and so I build a telescope around them. The first one I built was around a beautiful thin quartz mirror figured by Normand Fulham. Normand lives just near Montreal, and he makes some of the best mirrors on the planet for amateur astronomers, although he's moved upscale to 36-inch and bigger mirrors. So this one was actually written up by Gary Saronic and Sky and Telescope a year and a half ago. The second one, I built the biggest one I could that didn't require a ladder, which was 20-inch f4, and I'll show a couple pictures of it. And then most recently I built the one that I have here and that I took with me on the plane to South Africa. So in terms of the design and building process, this isn't, it sort of follows the high book, but it's not usually necessarily the way people do this, is I started with a mirror box. I added a secondary structure. I added and tested the altitude bearings. I built and tested the rocker box. Checked the focal length, because one of the questions is you can do a bit of arithmetic, but until you actually try it out, you don't know whether the focuser should be here or here or here. So that's checking the focal length. Actually, let me go back. Center of gravity is important because you don't want the thing to be tipping over to the horizon or to the zenith all the time. And then you're into an iterative loop to refine all of this stuff. So here's the first telescope. I actually brought it here and talked about it, I think 3 years ago. But you see me holding it with one hand, so it's not very heavy. And the mirror box is the telescope I showed you way at the beginning. There's a big square piece of 3/4-inch plywood. This is a 1/4-inch thin ply, rolled plywood shell, and it comes from a drum. So I went to a music store and said, "Do you have any drums you're throwing out?" which they did. And so I was able to pick up a number of these drum shells. And here's, in this case, the 6-point mirror cell, which are just the 3 teeter-totters. They're held in place by that piece of black plastic, which is one of those snow slides that you can get at Canadian Tire for kids. And easy peasy to build. That's the mirror cell. In this case, I didn't have a separate mirror cell. It was just integral with the mirror box. And there's 2 little pieces of fiberglass rod that are the edge supports there. Little yellow thing there. So the secondary cage, its function is to hold the secondary mirror and the focuser, but it can't be too heavy because it's out on this big, long lever arm, whereas depending on how you can do the geometry here, the primary mirror is only about there, so it doesn't have as much of a lever arm around the axis of rotation. So a little bit of weight up there can easily overbalance the telescope. The other thing is that you need to have some way of holding the secondary mirror out over the middle of the primary. Most often that's done with 4 straight vanes, but you get, in a lot of photographs, you'll see these 4 lines around the stars, diffraction spikes. Aesthetically, I don't like those, so the way to get around them is to have a curved set of vanes. It doesn't mean you have less diffraction, less light scattered over your field of view, but it's not concentrated in lines. It's diffused all over the field of view. A single vane is possible, but when you have the telescope at different angles, you have to worry about the flexure. In a conventional Newtonian or Dobsonian telescope, by having that rigid, big, solid mirror box, things stay put, so the mirror doesn't move around. But when you build something ultralight like that, that's something we do have to worry about. So I built, in that case, I used this curved piece of aluminum, a bit of glue, and a piece of wood with a 45-degree angle cut in it. It's thicker than typical vanes, but if you stop and think, I only need one of these vanes. It's a bit longer than a standard 4-vane spider, but it isn't 4 times as thick. So as long as you stay within there, you're not creating more diffraction. This one I went with a lightweight Orion 6x30 finder, which I generally find useful. I like to use U-clamps and bolts, pipe bolts, because that allows me to prototype, and in the end I never finish prototyping, I just leave them. I have to put in a minor editorial. I've taken 2 of my telescopes to Stellafane, and I'll never go there again because the judges claim to be open-minded, but they're really looking for telescopes that you could put in your living room as furniture. And I asked them before I brought second telescope, are you going to mark me down if I have a telescope that's got pipe clamps on it? And they said, oh, no, we won't do that. But in the end, they did. So just be warned if you ever think of going to Stellafane. They're pretty snooty. So here's another photograph of that curved vane. I'm interested in push-tos, and that's the essence of Dobsonians. Most of the time, I am thinking about motorizing these, and I have played around with that, and I'll come to that in a second. But a crucial thing about what makes Dobsonians wonderful is there's 2 concepts of having to move things. There's friction, which is once something is moving, once you're sliding, how much force does it take to keep it sliding? And then there's stiction, which is if something's at rest and you want to start it moving, how much force do you need? And the beauty of Dobsonian telescopes, they may not advertise it this way, is after a lot of trial and error, the materials that are used for the bearing surfaces are such that the stiction equals the friction. So it's buttery smooth. You can be looking at something, move it a little bit, and there's no jerkiness in the motion. So one of the things I had to do in building these telescopes was be able to reproduce that quality in the mechanics of it. And the experience is that Teflon on aluminum or Formica is what really allows stiction and friction to match each other. You don't want stiction and friction to be 0, otherwise you could use ball bearings all the time. But if I want to motorize this telescope someday by attaching some motors on the altitude and azimuth axes, I don't want there to be unnecessary friction. So the way around all that is to say, let's design the telescope so that from the get-go, it's running on ball bearings. It has zero stiction, zero friction, or as close to zero as you can get. But then we add some stiction and friction, in this case with Teflon on aluminum, in a way that allows us to make it fully adjustable. So it can be used both for manual push-to or motor-driven. So on the alt bearings, this one has the same ones as here, which are 15-inch diameter, quarter-inch plate. The machine shop out near Gary Sussex Place was able to cut those for me. And rolling on cam followers. And the Teflon allows me to adjust all that. How am I doing on time? Good? Or?
7-8 minutes.
Okay, no problem. And I've used Lazy Susan bearings for the azimuth axis, and so those are ball bearings, so very low friction. You don't want generally to have zero friction, for example, because if you're out on a windy day, it'll just blow the telescope around, and that's no good if you want to have it steady. So here's a close-up image, but I think it'll be better during the break or after. If you want to come look at this one, you can see how I've done the adjustable stiction and friction with the Teflon on the aluminum. Now another major trick, concern, and for many people a hassle or a mystery with Newtonian telescopes is collimation. Collimation simply means that you've aligned the mirrors, the two mirrors in the eyepiece in such a way that the light comes in, comes up to the secondary and goes out, and everything is appropriately aligned. With these kinds of telescopes, it's a bit trickier because I've taken it all apart. Normally when you take apart a Dobsonian, you lift the mirror, the secondary cage off, you put it one place, you put the mirror box another place, and there's a set of struts that are very rigid and well designed, so you just put it together, and a lot of the collimation work doesn't have to be redone, whereas here it has to be redone from scratch. So what is the trick? Well, at one point I had a Takahashi telescope. I sold it. But I was wondering how the heck it got collimated. So Takahashi, if you don't know, is one of the Rolls-Royce, along with astrophysics, kinds of telescopes on the planet. It's distributed by a company in Texas, Texas Nautical. Don't ask me how telescopes got to be nautical. So I called the fellow there and I said, how do I collimate this? And I nearly fell off my chair because he said, well, I just step back a bit and I eyeball it. You're kidding. No, it works. So what I've learned to do is basically, and it seems to work fine, is I just stand back and align the place where the secondary mirror goes so that it's centered on a center spot in the primary mirror. But before I do that, I have to make sure that the primary mirror is plane with the mirror box and that this thing is roughly perpendicular, ideally perpendicular. There. Then I can move this part around until when I look at it and stand back at the focal point, that circle is surrounding the dot on the primary mirror. Then the usual procedure of sticking a laser collimator in here and bouncing a laser beam. Adjust this so that it hits the middle there. Then adjust the 3 screws on the back so the beam comes back on itself and out. And we're ready to rock and roll. I was quite fascinated to read an article in Sky and Telescope, I don't know, 4 or 5 years ago, that got fairly technical about modulation transfer functions and all that, said that, oh, you're really shooting yourself in the foot if you're really more than a millimeter off on your collimation in a Dobsonian. But I have to say, based on my experience, either my eyes aren't that good or something, but as long as I get this within a millimeter or so, and I'm not too fussy, the images look fine. I haven't noticed any particular problem. The second telescope I'll show a few pictures on is the biggest one I've built. It's a 20-inch. How can I do that without having to stand on a ladder? One trick is to use folded optics. What does that mean? Instead of having the secondary here at a 45-degree angle, so the returning beam comes like this and like that, I put it at a 22.5-degree angle, so the beam comes down like this. And the other is to use very large diameter altitude bearings, that you'll see in a minute. I guess another trick for lightweight is tension structure. So here's a very large Lazy Susan for the rocker box, as it's called, the thing at the bottom. And if you look carefully, those little black things, the 4 of them, those are, what do you call it, inline skate wheels. So that's what the altitude bearings run on. Here's the mirror box. This case, it's a bass drum shell. And again, I'm just using a 6-point mirror cell with Teflon rods for the edge supports, pipe clamps to hold there are 2 stalks this time because 1 stalk just wouldn't have been enough, and bicycle wheels for the altitude bearings. And bicycle wheels are a marvelous invention because they're extremely lightweight and extremely rigid. And it just so happens that the width of those rims fits nicely over the rollerblade wheels. So here's the secondary mirror. You know, these are designed in terms of the minor and major axis of the mirror to be used at 45 degrees. So there's a bit of light loss or light problem if it's used at 22.5 degrees. But again, if you're not too finicky, who cares? Doesn't matter. And I've sent it into a 45-degree diagonal there, but the diagonal does add a line, and in experience you don't really need to have the diagonal. And this is what it looked like when in the left in my kitchen and in the right at Stellophane. And the stiction and the friction and all that are fine, and I put digital setting circles on it. The people at Stellophane thought it was great, the audience, but the judges didn't. So here's another picture. Easy to assemble, disassemble, fit into a car. So I don't know how many of you know of 20-inch Dobsonians that you can sort of pick up and carry around quite easily. And the third one is this telescope here. Again, I lucked out. I found this very nice f4 black vitreous ceramic mirror. I'd never heard of BVC, but apparently it has a very low coefficient of thermal expansion. It's hard to figure, but it's thin and cools faster. So I wanted this one to be airline portable. So the height of that drum shell for the mirror box is just a 1/4 inch underneath the requirements to fit under a seat. And the other design objectives were the same. And I've shown you this picture already of the telescope set up. And let me conclude. So everybody loves it, I think, is to look at M13 and Hercules. How many people think M13 is on the left? Everybody knows it's on the right. And on the left is 47 Tucane, which I spent a lot of time looking at. And I have to say, looking at it reminded me of Simon Hanmer's talk, I don't know, 6 months or so ago, when he was talking about how some globulars have condensed centers and others don't. So I was marveling at my inability to resolve the center compared to my memory of being able to resolve the more or less the center of M13. And that's all. Thank you very much, and I'll be happy to entertain any questions. Yeah.
All right, so if you have any questions for Michael, he'll be available at the break. You can go check out the scope and speak to him then. So we're going to do the break right now. We're going to take our time, a good 15 minutes. If you want to be back here at 8:40. We do have 6 issues of Astronauts that are printed out. Those aren't door prizes. They're grab them if you want one, come take one. So yeah, see you in 15. Okay, so you may remember this talk from a few months ago. We had a talk given by Sharon Odell, who at the time was a graduate student, about the Dominion Observatory and Mary Gray's work there. So now a few months later, we have a little update for you guys. So Sharon?
Hello. So the updates that I have this evening is because there's quite a few members that are interested in what's going on the Central Experimental Farm, where the Dominion Observatory is. And here's the site map, just to reorientate ourselves. So over to the far, I guess it's the left-hand side on your side, is Dow's Lake. And then Carling Avenue is at the very top of the map. And then, of course, there's Maple Lane that comes down the edge, and the Dominion Observatory. I don't know if I have a light pan around. I guess maybe it might be easier. Use this button here. That button there. Okay. So right, I believe, this is Dow's Lake, Prince of Wales, and then the Dominion Observatory is in this little area here. So what happened was there was a meeting back in late September, and it was with the City of Ottawa Developers Department with the Sean Moore, who was heading that. And they wanted to talk about the land transfer of the parcels of the Central Experimental Farm and also the NCC land, which is in front of Dow's Lake. And some RASC members, as well as myself, went to that meeting just to make sure that there was a mention of the Dominion Observatory in it, and asked about the sight lines and anything else. And basically what they were focusing on was the 12 hectares of land, which is the Central Experimental Farm historic piece that they were hoping to change from historical agricultural land to urban industrial. After that, there was a bunch of meetings in November and early December where they discussed some of the ideas with the actual architect, which is HDR. And this is the report that came out of it, which was published online in January last month, called the Feedback New Campus Information Sessions. And then within it, they said from November 22nd to December 11th for the engagement process. So on page 7 of the 10-page document, there is a mention of the Dominion Observatory. It's the second line in. So consider how the site would look from surrounding areas and what impact it might have on sight lines from nearby buildings like the Dominion Observatory. So it's not a lot of detail. It leaves out, a lot of questions to be asked, but at least there is a mention of it. Here's another map of the red outlined area, which shows what property is being transferred. The Dominion Observatory, I believe. This is Carling Avenue and Preston Street. So this is the NCC land. This is Dow's Lake. And I believe it's Maple Drive is here. So this is seismology number 7. This is Dominion Observatory. And the Red Barn Data Center in that area there. So this is Jason Emery Groen, who was with HDR, the consultant, and he was speaking this past week on Wednesday night. Some RASC members have mentioned that they went to this meeting. I unfortunately could not go to it because I was in Toronto. But they came up with the concepts, and this was held at Lansdowne Park in the horticultural building. This is the draft concept of the hospital that they gave so far, which consists of 3 half circles of building. And they mentioned that they will be about, can't remember how many stories high, but it looks here definitely. How many?
8 to 12.
8 to 12 stories high, yeah. And that's basically what the City of Ottawa was hoping to keep it not at, they were asking for 20, a height of 20 stories, but they were trying to keep it down below 12. And that's what it looks like in the landscape. This is what was published in the Ottawa Citizen as well, and online. So here is the NCC property, and that's the Dominion Observatory right there. That's Building 7. And this is the big behemoth wall at this side. This front area here that everybody was worried about keeping as green space. So this is the Arboretum and the herbarium, and the heritage hedges will have to be moved. So all of them will be transplanted elsewhere. But whatever else is here will obviously be changed. But under here, this green roof hides your underground parking garage. So there was a large contention with the public and the residents about the parking being above ground, which is cheaper, but also having more green space. So as far as I know, this is the plan that they've thought of so far. In this concept, the roads here, they have pathways, but they don't really show yet the access routes. That's going to come probably, they seem to be thinking last, but there's a mention that they're going to have to widen the roads because emergency vehicles such as fire trucks, etc., need 54 to 53 feet to be able to turn in and around. So they have alluded to talking about that more in the future. Here's what it looks like from Google Earth. So this is the property that the hospital site is taking. Here's the old hedges that will be removed, the tennis courts. This is the genetics building that they're very concerned about. Here's the Dominion Observatory up here. So this space here looks like it'll be salvaged, but this is right where the big wall of that last third semicircle is going to go. And this is where the parking garage will go with the green roof. And up here where you don't see it is the observatory house. That'll be very close, and the data center is very, very close. So this is on the City of Ottawa website. So if anyone has concerns about not just the Dominion Observatory campus and the buildings, but any of the buildings, heritage buildings or green cultural space on the site, can write to Sean Moore, the planner. Although a lot of these comments have been published, it's still something that they take into consideration. You can also write to the Ottawa Hospital. They have their web page and their contact list, and also there's Heritage Ottawa is also watching this very closely. And it's for comments not just about the heritage space, but also for the hospital itself too, because there's a lot of comments about light pollution, trying to lower and decrease that as well, and how it's being built, and then what programs should still exist, because there may be amalgamations of programs that come from other hospitals that come to the new civic hospital, and then there might be some that leave the hospital. So it works both ways. And now something that's been going on at the Dominion Observatory. Over the last year and a half, the observatory house is being restored, but also after almost 30 years, the sundial is finally being looked at. And I was just going to show some of the images. So here's the campus sign, and this is Building 7. And what started as a look at the historical building and what could be improved, etc., was the doors open that happened for the very first time, a new doors open spot, which was at Building 7. In the past, the Dominion Observatory used to have, back in the 70s and earlier, the public tours, educational tours, while the astronomy was happening in there, but the seismology building never really had those tours. And so it was a great success over the 2 days, the 3rd and the 4th of June this past year. They had a count of about 860 some visitors that came through. And the largest highlight was the tour of the seismic vaults that were underground. So this is an image of one of the seismic vaults down below. There's tunnels, of course, that go down in between the Dominion Observatory and Building 7. And that concrete slab that's in the middle is for the seismology machines to sit upon, so that they sit independent from the building or the ground around, so there's no vibration. Most of the machines that are on that slab, they're not working anymore. They're just there as such as museum pieces, just to explain how seismology and the equipment has changed over the years. And the gentleman, I can't remember his name at the moment, but he is the assistant to the head director, Dr. John Adams, and he gave the tour. This is the sundial that became a focus after the doors open, and there's been quite a few staff in the geological survey in earth physics that wanted to have it repaired and conserved. So you can see the number is the Roman numerals. Some of the Roman numerals were starting to peel off, come off. The concrete in between was starting to break up and to come apart. This happened. You can see a bend at the bottom because there was a service truck back, I believe, in 1991 that was delivering materials and accidentally backed into the sundial. And I believe this rod is called a gnomon, or gnome, the proper gnome, a gnome. And so that was bent and it's still kind of, it told time, but it was definitely not a nice thing to have happen. And so this was one of the primary concerns and reasons why they wanted to conserve it. But after 20, 25, 30 years, nothing was done until now. So this is what it looks like when it's in full bloom with flowers. It looks, aesthetically pleasing. And this is what it looked like on November 4th. They dug it up. There's a huge hole. And they reset everything, relayed the concrete. So all improved and new. Here's another detail look up closer. And another couple of details of what it looks like. And that's it in front of the observatory. And then they also have decided to give more parking for the Dominion Observatory and the seismology building. And I think that was due to the open doors as well, stating that there's a lot of visitors that are interested, and there's more interest, but also just to figure out the logistics of how to get people in and out. And there's also in between Building 7 and the Dominion Observatory, they put down new pavement, which had been called for a long time, and new sidewalks. So all of this has taken about 20 or 30 years, but we're starting to see things move and improve. And because that pavement there is so important, that's where the seismic vaults are in below. And they had done a large excavation dig up in 2014. So what was on top was just a layer of gravel after they had filled it all in again. And this was in need of repair. Here it is, all nicely done. After years of not having any work done. And this is a night shot on the 14th, so this is all filled in and all dry. The tarpaulin is taken off. And I just wanted to show the front entrance to the Dominion Observatory, just to let anybody who goes to the experimental farm, usually it's during the daytime, but if you're ever there at night, there's a beautiful full view of inside the front corridor. You can see the main pillar that the telescope used to sit on. And of course, Juan Gour's wonderful 1958 ceiling mural of astrology in reference to astronomy. And here we are on January 1st, last month, And they have it all cordoned off, and there's a new gnome in place. So you can see it from a different angle. There it is again. No bend in it anymore, all repaired. Up close. There it is. Finally, after almost 30 years, it's repaired. And I just thought I would reflect how old this is. This was made in 1911, the sundial, along the same time as the small equatorial observatory that is behind. And this is a film clip from 1919. It's Otto Klotz speaking to some of the Canadian National Film Board crew that came to do a documentary on the observatory back then. There's no sound to it because it's quite old, but there is subtitles. It's probably saying this is a beautiful sundial. Come see. And that's it. Thank you very much.
Can I ask one question? Actually, another one for you too. The Helen Sawyer Hubble telescope that used to be at the Science Museum has been put in storage.
Yes.
Is there any chance it could be put back into the observatory?
I have no idea, but a lot of people are asking that now that it's in storage. So it's an idea that you can put out there.
What was the question?
The question is, he was asking, now that the 15-inch telescope is no longer displayed at the Science Museum here in Ottawa, now that it's in storage, is there any chance that it could be reunited with the observatory for educational outreach to promote astronomy? And I said, I don't know, but it's something that can be brought up.
Is he saying who funded the repair of the sundial?
No, I'm actually still doing research, and I was going to actually present some of this in the spring when it was completely done and they had, re-gardened it and everything, but there was a spot for me to speak tonight. So I decided to show what I had for now, but I will find out and I can let everybody know.
There's some actions that I think the RASC needs to do here. First of all, there's changes which are afoot. The Booth Street building for Natural Resources Canada is being decommissioned, and Natural Resources Canada will be reallocated into different spaces. The current observatory building is just simply being used as offices, overflow offices for Natural Resources Canada, and eventually that will cease.
Yeah.
Okay, and beyond that, the heritage designations of the observatory buildings, if I understand correctly, are not at the highest level and should be.
Mm-hmm.
This actually, the observatory was built as part of the establishment of Standard Time. It's very significant. The pier, the center of the pier is one of the primary survey points for Canada. The idea that was put forth for year 2000, there was a set of millennial projects. This one didn't make the financing cut, but it was to turn the observatory into a science museum and emphasize the story of Sir Stanford Fleming and the establishment of Standard Time, emphasize geophysical research, which Natural Resources Canada and others have been doing in the area try and build it up as that kind of a museum, and hopefully go back to what occurred back in the 60s and 70s and before, where they had weekend observing and they bring in the public. We need a push for that, because it's not going to occur unless there's a body of people to push for it.
Correct.
I went to the meeting with the city where they had the announcing the design that you presented, I was quite encouraged to see that the parking will be underground. The building will be a partial obstruction, but it doesn't look like it's going to take up that much of the sky, and it looks, and the architect was actually talking about those will be patient rooms along that side, and they're going to try and keep the light levels down. We might have an opportunity here. We need to push it. First thing we need to do is members have to get onto the Ottawa Hospital comment site and actually make comments that we want the Dominion Observatory to be preserved. That if we don't do that, they'll just build what they need to build at the cheapest price. The second thing is we should be pushing the federal government to build what would be an actually very good tourist attraction. If anybody's ever been to London, England and seen Greenwich, well, this is just as significant. There's, at the end of the building, there's this sort of a low part of the building with these slot type roofs. That's where the old transit circles were. And those are actually more important than the main telescope. That's where the positioning of the continent was established. There's a telescope now gone, which was which was the vertical zenith telescope, which was used to measure the movement of the continent. One was in Washington and one was here, and the movement, continental drift, was established by those two, and one in Paris, London, and Moscow, the vertical zenith telescopes. Good history, but that equipment's all gone now. There used to be a spectroheliograph at the back of the building, now a parking lot, which, if they put back in, you could even have as a tourist attraction during the day with I think they had at that time a 6-foot sun image. We need to get behind pushing the appropriate people to build this as a project. I think Heritage Canada at the moment would be receptive.
Yes. Well, thank you very much for bringing that up. I have been looking at research and the many times that it has been brought up in the past as well, just to sort of recirculate the ideas. And back in 1974, there was many letters. Of course, they were letters to Heritage Canada, to the Prime Minister, Pierre Trudeau, to different factions concerned about the removal of the telescope, and this being the beginning of the end for the Dominion Observatory, the building being lost without its equipment. And just looking at the wording and what was said then and why is it so important. Now, of course, the telescope was removed in the end, and that was because they wanted to try and continue the education at the Science Museum. And the building, of course, now we know it wasn't demolished in the end. They thought that it would be. But yes, this is something to think about. And the architect, when I spoke to him, he had not heard about the Dominion Observatory. He did not know much about it. There was a team that was there, and I actually got to speak to one of the head architects. And this was back in December. I went to one of those meetings. And when we brought up the information about the building, they started thinking about it more. And also it was brought up again in September. And so every time it's brought up, it then starts to get onto the main records of, okay, we have to think about this now. So every little bit counts, and it's something that doesn't happen unless the input is put in. So it's a good thing to mention.
But an action should come out of this meeting.
Yeah.
Where we could distribute it on the by email to people, but ask people to get onto the City of Ottawa website give the address where you can actually lay comments. And the comment should be, don't preclude the eventual use of this as a science museum. Don't build a hospital as a flare of light.
Mm-hmm. Okay. Well, thank you very much for your comments.
Okay, so we're going to switch things up a tiny little bit tonight. We're going to start with observations. And at the end, we're going to have a bit of a longer mini talk observation type of thing. So we are probably going to end a little earlier than usual.
Good evening. Rajesh Joshi last month has presented great pictures from a wonderful place, Saba Island, where you can always expect great things in the skies. This is alternative, which is our location here. This is the FLO Observatory, and when Rajesh was back from Saba to Ottawa, we took a trip there, and this is what we saw. So, of course, we were expecting, as usual, to get some patches of clear skies, which that night was a very rare occasion. There were still sucker holes, and we managed to see Orion Nebula, Andromeda Galaxy, and Pleiades through them. But mostly, as you know, last few months was like this, and I called this picture me making steam in the doorway of FLO Observatory by collision of hot and cold air. So, and you can see a little bit of the new telescope operating there. It's a wonderful device, 18-inch, very contrast, but unfortunately lately with overcast it was difficult to get some nice pictures or at least views and do some observations with your own eyes. However, I have some pictures from, oops, I think it's wrong button. From before, I took it last year. This particular was done in June 2017. This is North American Nebula with Deneb will be somewhere here. It's in Cygnus constellation. Mostly it's a hydrogen gas glowing bright because of surrounding stars. There is actually regions where stars are born. This is open cluster, and I think there is another one somewhere here. So it was quite a dim object, and the special about this picture and the others which I'm showing today is that they're not taken with a telescope. There was a mirror lens, 500 millimeter diameter, which was attached to a regular DSLR camera. Well, it's regular, but a modified camera where the filter was removed to increase the sensitivity to hydrogen alpha. That explains this red glow, which is hydrogen alpha glowing, being excited by the energy from the stars. Another object is middle of summer in September or late August. We went to Plevna, which is an observation spot, one of those which kind of are friendly to RASC members, southwest of Ottawa, about an hour and a half, actually rather closer to 2 hours drive from Ottawa. It's a very dark place, one of the best for observing the skies around Ottawa, and well, you know Andromeda Galaxy pretty well. It's again, I'm kind of proud of this because so far it's one of my best shots of Andromeda, and again it's done with a 500 millimeter mirror lens, no telescope. It's a guided shot though, so I was using the mount and the guider. And again, same story, it's Plevna again. Oh no, sorry, this was from the FLO grounds quite recently, and when it was quite cold, about lower than 22 degrees. I tried to use again this very same FLO telescope for observations, but electronics failed to work because of low temperatures. So I still did have a chance to take some pictures that night. What's interesting, you know, this, oops. How can I go back? what's interesting about this is this object here that I read about is the NGC 2023. It's both reflection and emission nebula. It looks as a star with some nebulosity around it, and it's not that big, but apparently the dimensions of this object is 4 light years diameter, which makes it one of the largest reflection nebula in our, at least those that we are aware of. It's quite amazing object, and for the rest, you know it very well. The Horsehead, the Flame Nebula, they're just a little bit below this bright star here, which is in the Orion belt, which goes like this. And this is Alnitak star, the one on the left of Orion's belt. Thank you very much.
So I'll be speaking to the next few photos just because the artists aren't here to present them, obviously. So these are by Peter and Deborah Saravola. And these are just pictures of the eclipse a few days ago. I don't have much more information. But this was, I'm guessing it was taken in the Okanagan. Nebula. Okay, thank you.
Well, hi, everybody. I didn't even actually know that we were going to have other eclipse images there. I was out a couple of days ago shooting that eclipse, and just out of curiosity, anybody else see that or go out and have a look? Oh, wow. Oh my God, that's amazing. Because it was an early morning event, and the skies weren't all that promising. Anyway, see if I can advance this properly. No? Yes? Yes? Oh, there we go, finally. And yeah, I was out a couple days ago myself and trying to see this eclipse, and then Kelly told me that we had a few extra minutes, and Chris mentioned that, and I just want to thank Kelly for prompting me to, you know, take my time and, you know, extend my talk a little bit, because I tend to rush things and be very short. What? What? Anyway, so I thought, well, what can I do with this? The eclipse itself from Ottawa was kind of marginal. And it got me to think, like, I've sung this song before, because the last number of eclipses from Ottawa have been pretty dismal. So I looked back in my records and I thought, okay, well, I can do a little summary on this and probably tie it in a little bit with some of the stuff that I want to present in the near future on our Imaging Corner segment there. So eclipses are a great target for that, provided you have clear skies. And so I thought I'd just give a bit of a preamble on that. Probably next month or the month after, we'll do something on the from the eclipse corner, the Imagers Corner perspective there. But for now, I'll just show you what we have. I had a look back at the last 10 years, and my focus here was total eclipses that you could see from Ottawa, or very close to the city. So these are the total ones. You can see the one that we just had is the second from the bottom, and the last entry is yet to come there. So essentially, we've had 4 total lunar eclipses that we could theoretically see from within Ottawa, and that was the one from 2008, and as I recall, that was a very splendid night. That was beautifully clear, and I think a lot of people got a good view of that one. And so that was nice, and I like eclipses because they're different, they're dynamic. Many of the things that we look at, especially when we're doing photography through telescopes, tend to be things that don't change that much. If you're talking about, you know, galaxies or nebulas or such things, Obviously the planets and are different, but many of the objects tend to look the same from year to year. Your techniques may improve, your equipment may improve, but the object itself doesn't change by that much. Eclipses, on the other hand, are very dynamic. They change in the course of just minutes or hours, depending on whether it's solar or lunar. And so I enjoy shooting lunar eclipses. So February 2008, right? So almost just about 10 years ago. Next one, December 21st, 2010. Nada. Cloudy in Ottawa. So we had to wait until April 15th, 2014. Nada. I know I'm singing a song that a lot of people here have been singing too. It's we haven't had a lot of luck. I guess that's my point with this, is we haven't had a lot of luck with total eclipses of the moon visible from within the bounds of Ottawa. Fast forward to just September of 2015. We had an eclipse that was beautifully positioned in the sky, nice and high. September, reasonably warm. And indeed, I was able to see this, but only because myself and Eric and a few other folks journeyed down to Upper Canada Village. We looked at the satellite images on that day and we thought, oh man, Ottawa's going to get skunked again. We need to get further east to be able to see this, and we lucked out. We did see most of the, we saw all the beginning and we saw well into the totality phase and got some beautiful shots of that eclipse. But for those in Ottawa proper itself, guess what happened just as totality set in? Yeah, those that observe know, right? So we had this. This is again a bit of a tie into to time lapsing and the kind of stuff we'll talk about in Imagers Corners coming up. But one of the things I was doing down there for that particular eclipse was shooting a time lapse. This was just with a 16 millimeter lens set with a camera on a stationary tripod, and let's see if we can get that to run. You can see that this is we had nice clear skies. There is some wisps of cloud down at the bottom there, and I think about halfway through the totality phase, there we go, right? You can see the clouds moving in. But we were east of Ottawa, and Ottawa got those clouds just as totality moved in. So, yeah, rather frustrating. The time lapse is interesting, though, but that's one of the things when we talk about the Imagers Corner segment. It's not only what you do with your equipment and that, but if you're looking to do time lapses, location is also an obvious consideration. One of the things you want to think about is, if you're shooting with a wide-angle lens, you want to get something scenic in front of that. This particular vista was right on the St. Lawrence. You can see when we run the time lapse there, one of the Laker freighters going from left to right. So again, it's just one of those considerations. You also have to know when and where to shoot. So September the 27th, even though I did luck out and get some really nice shots of that from Ottawa, and nada. Again, we haven't had a lot of luck. So fast forward to 2 days ago, I added this one just because it is current, and I was going to show these couple of images that I did take. Certainly the images from the Ceravolos are much nicer. They had a full vista. We theoretically would have seen, we did see just the moon starting to move into the umbra before the moon set. So another thing I want to draw to your attention, again, for those of you that have been sort of following along on the Imagers Corner segment, tips and tricks and such, if you're not aware of this website, this is an awesome site. It's timeanddate.com, and it's just chock full of useful astronomical information like sunsets, moonsets, length of astronomical twilight, when astronomical twilight actually begins and ends. And you can put in whatever location you want. So you get a whole pile of data generated, including eclipses. And there's an interactive animation that gets generated for the eclipse that you choose. If you run this is just a static image, but if you run this, it'll show the progression of the eclipse, the phase. And what I really like too, and I hope I'll press the right button here, there we go, is the data down here. It'll give you the precise times, but it also gives you where to look. So if you picture a compass with 0 degrees being due north, and you sweep around to the east, down to the south, out to the west, and then back up to north, you cover a 360-degree circle. So again, for shooting time lapses and things like that, this is a really handy tool because it'll tell you where and when these different phases of the eclipse actually occur. So for this one, for instance, we had maximum eclipse, even though it was just partial. This was right at sundown, or at moon set rather, and you can see there's the altitude. It was just at the horizon, but more importantly, it tells you exactly what compass direction that this would occur. So if you're out in an unfamiliar place or you're trying to scope out a location to set up your cameras, really useful information. So yeah, timeanddate.com, it's a well-recommended site and very useful for your astronomical work. So this eclipse that we had 2 days ago, as you can see, that's about us there. And we only got the partial phase, and just as the moon was moving into totality, or into the umbra, the dark part of the shadow there, I had actually contemplated perhaps going to somewhere between Sudbury and Sault Ste. Marie, where you would have had to go to catch any part of the total eclipse at all, even though it would have only been a few minutes. But it would have, if the weather had been clear and it would have, you know, and the roads, I mean, that's a long way to drive, but if the conditions had been suitable, I might have considered doing that, because it would have been nice to catch that moon going into full eclipse just as it's heading down to perhaps the horizon on Lake Superior. As it turned out, pretty much anything west of Ottawa was totally clouded over, and yeah, that's a long drive to make when conditions are less than suitable. So I thought, well, let's just take it in from Ottawa and see what we get. And oops. This is what we had. This is what we were looking at. The partial eclipse actually started at 6:48, and totality began at 7:52. Here in Ottawa, the moon set at 7:27. So you can see we didn't quite make it into totality, just got into a bit of the partial phase and the moon moving into the umbra. So I only got really, as it turned out, the clouds moved in a little bit faster than I had anticipated. And within a couple of minutes after the moon entering into the umbra, into the dark part of the shadow, the clouds started to move in, the moon started to haze over, and we got that there. So you can see certainly a little bit of detail there of a lot of haze there. The sky was brightening up quickly because the sun was also rising at 7:25. So we were only less than half an hour here from sunrise and well into the dawn light. So that was one of my initial images there, and the other one I got was a few minutes later there. This is about the last good image that I got, and you can see the part of the moon that had entered the umbra there, but a lot of haze around there. And I had hoped to do a time lapse of the setting, so I was looking for a nice flat location where I could see perhaps the moon going down to the horizon, but oops, let's go back one. But yeah, that's what happened about 2 minutes, or about a minute actually, after that last shot. So time lapses weren't going to happen, not for this particular eclipse. So did get a view, and I'm glad a lot of people had a chance to actually go out and see it. I think for those folks, actually, I was shooting this to the west of Ottawa, so the clouds came in for me a little bit earlier. For those of you in Ottawa, you probably got a better view of this. I did see some local pictures taken, and it looks like the clouds took a few more minutes to enter Ottawa airspace, and you probably got a better view. But again, it wasn't a total eclipse. The next one of those, here we go, 1 year, or about 11 months from now. So again, for those of you following along in the Imagers Corner segment, you have about 11 full moons to practice with your telephoto lenses and such to try to pin this down. And in the meantime, if you're out, especially in the summer and the fall shooting, again, I recommend you check out this site, because again, it'll start to give you an idea of what's required to set up for doing a time lapse with pleasing foreground objects, and also make sure that you have a nice clear vista of where the moon is actually going to be. That eclipse in 11 months from now, It'll be our first really nice one since 2015. It'll be total. It'll, as you can see, total eclipse begins. It's not super late at night. It's quarter to midnight there, and it'll be at about 64 degrees elevation. So we get the whole thing. It's in January, so all we have to do is bundle up and hope that our bad luck on total eclipses doesn't hold. We'll cross our fingers. Take care.
I'd like to mention that Paul only went 3 minutes overtime, which is a dream come true. Okay, thank you, Paul. So just for our final announcements, next FLO Star Party, February 17th. You'll be receiving an email before that about the go, no go. Estelle's Pick of the Month, Higher Than Everest. This is a book specifically about exploring the planets of the solar system and their surface features and their geology. The next workshop series, it's Thursday, February 22nd, and it's with Brian McCullough about the moon. So I think you may have already or will receive an email about this, and so just be sure to RSVP. Membership, as usual, you get benefits such as the Ted Bean Telescope Library, the Stan Mott Book Library, and access to the grounds of FLO, as well as these 4 publications. So our meetings are not yet being live cast, but they are being filmed again, up and running. Thank you to Mike Bois. So I think we'll be getting a little more information on that shortly. So thank you very much. 98 people. That's not bad at all for February. And of course, this is my last meeting with you guys. So I just want to say thank you for an incredible year. If I can have a parting message, it's for youth members. I see a lot more younger faces here than when I started 2 years ago. And for youth members, just get involved. It's so rewarding, and there's so much that you can do, so much that you can change. So really get involved any way you can. There's lots of opportunities. So post-meeting at Perkins, I can't tell you where it is, but it's oh, I know, it's right past Gracie's.
Right across the road from Saint Laurent.
Okay, right across the road from Saint Laurent. Okay, so next meeting, March 2nd, is that right? So your new meeting chair will be Oscar Echeverry. Are you here?
Right here.
Yeah, are you going to want to introduce yourself next time?
Yeah, sure.
Okay. So he'll be starting next month. Now, there are more door prizes than there are door prize tickets. And I don't want to embarrass myself on the last night, so I'll just let you have your grabs. Just make sure I don't have any to take home, because I'm not bringing them back.